Hello everyone. Today we are going to solve question number 3 of the series. Let's begin with question 3. How are polynomials represented in computer? Write an algorithm and flowchart to evaluate polynomial given p of x equals to the equation. Compare the efforts in multiplication number and addition of brute force method with the recurrence relation method. B. Write the recurrence relation of dividing this polynomial by x minus r. Let's begin with the solution. A polynomial p of x is an expression in variable x which is in the form of this, where a1x are the real numbers and n is a non-negative integer. N is called the degree of polynomial. Every term in polynomial commits of a degree and coefficient n is the exponent. We will obtain an algorithm to evaluate the polynomial. Evaluating this polynomial by brute force technique is simple but will involve n plus 1 by 2 multiplication and n addition. In the algorithm which follows, the number of multiplication is divided to n. The algorithm is based on the following alternate method of writing an expression. P of x can be written in 3 different ways. First, we're gonna write it in a simple way that is given in the equation. Second, we're gonna take x common and write all a1 plus a2 term together. We're gonna take again x common and write all these equations in the form of a2 and a3. Let's come to the algorithm. Let's begin with step 1. We're gonna read x and n. For I equals to 1 to n, in step of 1 do read a of I and 4. P equals to n means we're gonna assign value of a n to p. For I equals to x to 1, in steps of -1 do assign p equals to ai minus 1 plus xp. Write p, stop. In the above algorithm, the for loop set up by instruction step 2 consider of only one element statement, namely read a of I. This statement reads the array a0, a1 up to an, which is used to store the coefficient of the polynomial. The for loop set up by step 5 also has only one step instruction, that is instruction step 6. Let's begin with the solution of B part. What this B part says, let's first see that. Write the recurrence relation of dividing this polynomial by x minus r. Let's come to the solution. We will consider the problem of dividing the polynomial where r is a root of the origin polynomial. The long division method is like this. We're gonna divide the equation by x minus r as we have asked in the question. By dividing this question, we're gonna get our answer as a of n x to the power n minus 1 plus a n minus 1 plus r a n bracket close x n minus 2. We will call the reduced polynomial b n minus 1 x n minus 1 plus b n minus 1 x n minus 2 so on plus b0. The equating the coefficient of the above problem with the quotient obtained by the division above, we get b n minus 1 equals to a of n, b n minus 2 equals to a of n minus 1 plus r of a n, b n minus 3 is equals to a n minus 2 plus r bracket a n minus 1 plus r a n bracket close. In general, we're gonna get a term like p of n I plus 1 equals to a n minus I plus r b n minus r. Algorithm polynomial division. For I equals to 0 to n, in step of 1 do read a of I and for loop. B n minus 1 assign a of n. Assign the value of a of n into b n minus 1. For I equals to 0 to n minus 1, in step of 1, do assign value of a n minus 1 plus r b minus I to b n minus I plus 1. And 4. For I equals to 0 to n minus 1, in steps of 1, do write bi. And 4. Stop. The above algorithm is very useful in reducing polynomials by removing the roots and may be extended to cases where the polynomial is to be divided by a quadratic factor. That's all for this question. Thank you.